Welcome to episode 28 of the all-wheel drive Mustang project, Project Traction. Well, I'm excited to announce, yes, I did get a supercharger for the car. People who watched the last episode at the very end, I did a little sneaky reveal, but yes, I'm partnering with VMP Performance and I am installing a Odin Stage 2 supercharger, and with their tune, at least for this season, to see how it goes to prove out the all-wheel drive system. But that actually isn't the main focus of this video, so I'll get into it here in a second. But basically, I mocked up the supercharger, and I wasn't shocked at all. I knew this was going to happen. I had some clearance issues with the K-member, that bracket that goes between the strut towers and the firewall, and also it was pretty close to the hood. And I had made a decision a couple of years ago. I was kind of obsessed with the CV axle angles, and I had raised the engine up. My motor mount system had raised the engine up 3/8 of an inch, maybe even more than that. Kind of tough to measure, to be honest. And obviously, all the superchargers, all the various brands, they're really trying to squeeze a lot of stuff in there, and there's not a lot of clearance to the hood, right? And so most people actually lower the engine down with brackets by various companies to get more clearance. And I had raised it up. You know, with the stock intake manifold, there's miles of clearance. You can raise it up. You probably could raise it up an inch, and which would be good for CV axle angles. But after I got it all running last fall and driving for many months, I'm convinced now that that was just not needed. And if I ever were to do this again, not promising anything, but if I were to do more of these, obviously I have to design it around being able to put all the various superchargers on it, including the VMP Odin, which I'm excited about. And so it was not VMP's issue at all, it's mine, you know, who would raise their engine up. Anyway, so I had to work on that, and that's going to be the primary focus of this video, is how that interacts with the motor mounts and getting the engine to be back down to stock level with some adjustability. Actually, the new system allows me to go even lower than stock, and I wanted to get all this done before making the new axles in case the lower engine mount does affect the length of the new axles. So the last video I made the jack shaft that goes through the oil pan, and really the next task was to make the axles. But once I mocked up the supercharger, realized I really wanted to redo the motor mounts and the front crossmember anyways, for various reasons I'll get into, that I should pause the axles until I get the engine in its final position so I can accurately measure their length. And so let's get into the motor mount discussion. Okay, so after mocking up the new VMP Odin supercharger and realizing my decision from several years ago to raise the engine up 3/8 of an inch was going to cause an issue, I decided that was a good excuse to do some upgrades to the front suspension. As I've already talked about in previous videos, I wanted to redo the engine mounts anyways from an NVH standpoint, and so I was using these more race-oriented polyurethane engine mounts. And then these were my original brackets that bolt to the chassis that were kind of meant to be just temporary anyways. These were just mock-ups. So basically, unlike the factory setup, so this is the remnant of the factory crossmember here. I'll insert a picture of that. But the stock motor mounts bolt directly to the crossmember. So what I did when I redesigned the front suspension is I had the motor mounts bolt to a bracket that bolts to the chassis, and then the front crossmember bolts to that. That way, with all my iterations of taking the front crossmember on and off, the engine could stay behind. And so that worked out quite well. And this was my proof of concept of that, and everybody on the internet basically told me how this sucks and all my welds suck, but you know what, it worked just fine, and it proved the purpose. I guess it proved the theory that this was going to work. And I also then made the driver's side used the production aluminum bracket on the engine side, but the driver's side, to account for the relocation of the motor mount and to tie into the differential I made this new bracket, basically engine side bracket. And once again, the internet is very harsh when it comes to welds, even though I splashed across the screen if this was also originally, and it proves out to be true, a temporary engine mount. But anyways, the stock engine mounts are these hydraulic things which are way too big and would never allow a axle to go underneath. So basically in the stock setup, the engine mounts are almost perfectly in line with where the axles want to be for an all-wheel drive conversion. And so there's just basically no way to make these work. I did ponder, kind of like this is the passenger side. I did ponder moving the motor mount back in the chassis or forward in the chassis to get it to clear the axle. And if you look at a lot of all-wheel drive cars with the longitudinal engine, that's what they do. Like the Nissan GTRs, for example, have it in front. Well, there's all kinds of stuff in the way on the Mustang, the AC compressor, for example. And I was concerned if I moved it back, it would start interfering with exhaust. So I decided to change out the motor mounts, but go with a different short version. And so I've settled on these. And these are made by a company called Vibratechnics. And so why did I choose these, and what are they for? Well, these are actually meant for a Ford Escort Cosworth, or an all-wheel drive Ford Sierra in Europe. And this is what I've used for literally 20 years in my all-wheel drive V8 Turbo Merkur. And they've worked great, and unlike a lot of other aftermarket mounts, they actually are still a vulcanized rubber, and they kind of specialize in getting the right combination. This company specializes in more kind of road friendly but yet stiffer mounts, and I'm hoping this is like the Goldilocks combination of limiting the motion and yet still having reasonable NVH. Because that was another reason why I didn't just take the stock mounts and move them back, is that they do a great job of reducing the NVH, but I actually think they're really too loosey-goosey. I want something in between. I want kind of this Goldilocks thing, right? So I'm hoping this is the case with these, that these will be kind of a Goldilocks solution. We'll limit engine movement to keep the CV axles under control, yet we'll have low NVH. So basically, but this required redesigning all these brackets, both the engine side and the chassis side. And so the first step on that was redesigning this chassis bracket. So first I laid the whole thing out in CAD, Fusion 360 in this case, and this is my first attempt as a 3D printed model. And I actually bolted this to the car. Obviously it can't take any weight, but it proved everything out. And to create that model, I actually put the piece of chassis, I put this piece in my milling machine and kind of used the milling machine and the probe and the height as kind of a coordinate measuring machine to get all these dimensions. One of my future goals is to get a 3D scanner, but I don't have one yet. So to find basically all of these factory positions, I just put this bracket in the mill and probed it to kind of get all the dimensions. I then took those dimensions, did all the height calculations, and designed this. I did a pretty major revision before machining it. On this channel I've done a lot of scenes of machining aluminum things. So in this, I'm not going to go through that again, but here's the final product, which well, turned out fantastic. And basically this bolts to the chassis with these two holes here, bolt right to the stock studs that come out of the chassis. And then these bolts are for tying in the front cross member, and obviously these are for the new Vibratechnics engine mount here. So This is the right-hand side, or the passenger side. I actually labeled it here with the mill. Yeah, so the only thing I'm going to show you is I was pretty excited about the machining of this chamfer. I'll insert a shot of that, but I won't go through all the steps of machining this again, because I've done a lot of that aluminum machining on this channel. If people want to see more, let me know and I'll make another video about it. But anyways, I made two of these. One for the left side and one for the right side, and they are different because it turns out, which I didn't know until I measured this remnant of the crossmember, is that relative to these two chassis mounting locations, the motor mount is not centered in between it. It's actually spaced back about 1/4 inch. Don't quote me on that, and so there had to be a dedicated left and right side for these brackets, because once again they're not centered. So once this was made, or to make this, and once this was made and to make this, I had to incorporate, what was my height going to be, and basically I needed more room than the stock aluminum brackets would allow. So kind of the cascade effect of wanting to lower the engine back down to the stock height for various reasons. I wanted to remake the motor mounts anyways from an NVH standpoint. The brackets that bolted to the chassis were always meant to be temporary, and so was the driver's side engine bracket that once again everybody said my welds were sucked. But anyways, the internet has been really extremely supportive of this project, except for my welds. Even people who are positive are like throwing me under the bus for the welds, and it's just like, well, the thing works, so let's move on. Anyways, so the new scheme to lower the engine down to stock height, which I wanted to do anyways for clearance for other things, required making basically new engine brackets. And ultimately I was going to have to also modify the front crossmember again, because basically the first version, the rack was really already too close to the cross shaft, and lowering the engine down 3/8 of an inch would obviously just not work. So I would have had to basically cut up and redo the front crossmember and make all new brackets, and which was, to be honest, fine. I had kind of accepted that. And I thought to myself though, but as part of that, does it make sense to upgrade to a tubular front crossmember to save weight, and more importantly make it easier to fabricate and to get more access, like get better access to the diff or changing the oil and things like that. And so I'm proud to say that I reached out to BMR here, and they were happy to help support the project. And so they sent me the engine side brackets unassembled, just the raw parts, and then sent me their street version of their tubular front crossmember for the S550 Mustang, unpainted. They were fully aware that it wasn't going to fit stock, neither part. And they've been very gracious, and they sent me the front crossmember unpainted, and the engine brackets, not welded together, so I could tailor them to my application. The BMR engine side brackets already are raised up about 1/2 inch, and then they send you 2 1/2 inch or 2 1/4 inch spacers to make the difference. But I wanted to raise it up even more, and hence they sent them to me in parts. And so I made this jig to reference the stock aluminum bracket to have a frame of reference, so when I welded the BMR brackets back together, basically, it would be accurate. And so here you can see the jig that references the stock aluminum engine side bracket. I then used some spacers between this jig and the BMR components to set the height I wanted, to basically move the whole motor mount up in the chassis even higher than what the BMR mounts with no spacers would allow. I wanted that extra flexibility so I could actually play with the engine height versus my original setup. I was kind of stuck at 3/8 of an inch higher and I couldn't go any lower. So now I'll have some room to go lower or higher. Here's a good angle. It kind of shows the whole idea. You know, here's the aluminum brackets that bolt to the chassis. Here you can see the modified BMR bracket that bolts to the engine, and how it's all self-supporting. This is the same concept I had in the car before, but just revised and dramatically improved on looks, that's for sure. But so basically we got the new aluminum part, the new engine mounts, and everything's self-supporting, so now you can take the front crossmember out and the engine can stay behind. But what's left, and I'll show some detail on the passenger side, is I want to tie in a part from the oil pan to this side engine bracket to try to triangulate the oil pan, and then I also need to add the gussets to the BMR bracket for the triangulation of the differential back to the engine. And here's the final version before coming out one more time just to get some paint. You can see how it ties into the diff cover and to the bracket that was there for the old motor mount, but it couldn't be more delighted how it turned out. And after a little VHT chassis and roll bar paint, she's ready to go back in the car for good. Similar to the differential, I added a new gusset that goes between the bearing that supports the jack shaft and the driver's side motor mount to try to help support the oil pan, since it is taking all the loads of the front differential. Here she is, the BMR Tubular Crossmember. This should be a huge asset to the car. Not only does it save some weight, but it should make it easier to relocate the rack and has more clearance for the differential. I will have to modify it though. They send it to me basically unpowder coated or unpainted per my request, because I'll have to modify it. Obviously this is set up for the stock motor mounts and to mount directly to the chassis, so I'll have to cut it off and modify it. BMR knew that going in, but they're very supportive of the project. I'm starting with BMR's street version of their K-member, which is KM760. So it has the outriggers that tie into the chassis in the back, and then it also has provisions for the sway bar, which of course I want to use, and is set up for the stock motor mounts, unlike their drag version, but I'll be cutting that off, so that's kind of irrelevant. But the sway bar attachment is important to me. So anyways, it's a beautiful piece, and I'm looking forward to making it work in my all-wheel drive application. The first step in the modification was marking and cutting off the stock chassis mount near the motor mount to take into account my aluminum brackets I already showed you earlier in the video. I used the laser to try to keep everything straight, and it worked out pretty well. So here's my next major mock-up with the new BMR front crossmember. As you can see here, I've cut away some of the existing material to get some clearance. It'll need some further massaging, and I believe the engine is at quote-unquote stock position or stock height relative to the chassis. On the other side of the car, the driver's side of the car, I actually have the factory aluminum bracket on the engine, the factory motor mount going to the factory going to the BMR crossmember, which utilizes the factory mount. And then on this side, I have my new aluminum motor mount bracket I've already shown with my new softer rubber motor mounts, and then the BMR brackets on the engine, which I've modified to raise everything up about a little over 1/4 inch higher than stock. I might have done a little overkill. I got tons of clearance here actually. So the next mission is I'm going to flapper wheel all this in clearance, get this piece out of here, and actually take this sheet metal off, which was this rough right now, and machine the outside of it to final spec, and then start constructing a bracket or a gusset to go across here, shave this down a little bit, and then have a gusset. I think the current plan is to have a gusset that goes across and then have another bracket kind of like this one that comes up off the main tube, comes up, clears the CV joint, and then intersects the steel bracket or the steel plate on the bottom of my aluminum bracket. to try to triangulate around and have clearance for the CV joint. The goal in the bottom here is to have at least 3/8 of an inch, if not more, which I think is quite doable. I want to have some room to be able to even lower the engine down below stock for supercharger clearance and other reasons. But the next, after I get that done, you'll see that there is clearance here. It's hard to see, but the diff does get really close to this tube. So I'm gonna maybe grind on the diff a little bit and maybe notch this tube or deflect it a little bit, but it's really close. In general, this crossmember, this tubular crossmember, does have a lot more clearance, which is the whole point. I had to really butcher the stock one to get to clear the diff, and this one it's just going to require just a minor notch. I've also already cut off the passenger side mount for the rack and pinion. That'll have to be moved just like before, which is what instigated some of this thing. Is once I had to lower the engine back down, I would have had to have completely redone my crossmember anyways, and so if I'm going to do that, I might as well do the tubular one. So once again, thanks for BMR for providing this. It's going to turn out fantastic. The part cleaned up really nice after a little bit of flapper wheel action, and then I proceeded to use the mill to clean up the sheet metal part that bolts to the aluminum bracket on the chassis. And then also CNC machined the new gusset that goes between the main tube and the body side bracket. And here's the mock-up of the right hand side, the new bracket I machined. Just using some off-the-shelf materials here for a spacer to keep everything level, and using a digital protractor to reference it to the other side to keep everything straight. I did add a little bend here to get to clear some of the existing holes, but anyways, I now have plenty of clearance to the CV joint, and she's ready to weld in place. I then reinforced everything by adding a few gussets and brackets before repeating this whole process on the other side. After getting the front crossmember modified for the CV axles, the next task was getting the rack and pinion mounted. This is the basic mock-up. There's a whole lot of variables here how to keep this, how to get the rack in the right position. So you can see I marked the center of the crossmember relative to the car, and then used the laser. And here's a mark on the rack and pinion, the center line of the rack and pinion, and then use these jacks to get it level, also using a laser to get it level, and then shims to get it as close to the features I care about. I basically wanted it as far back and as high as possible while still clearing the now lower engine and getting a little more clearance to the jack shaft. So I made these brackets and then tacked them to the crossmember here. Obviously it needs more welds and it needs some gussets to tie it back. But before I burned it in and made it difficult to modify, I did a sanity check. So since I lowered the rack down even more, I wanted to verify my bump steer kit would work. So I broke out the bump steer mirror system again here with the laser and the piece of cardboard, and tried some different spacer options, and I had to lower it down by basically 2 spacers, this thick one and this really thin one actually, and that really dialed it in. So I must have basically, I don't have a good frame of reference, so whatever that distance is how much lower the rack is, and it's slightly moved forward too. So what is that, maybe 1/4 inch or something like that. It's lower than it used to be. And here's the mounts roughed in, actually tacked in. I'll take it off the car now and clean up the welds. And here's the completed front crossmember after all the modifications. I basically got the new rack mounts in there, and somehow I got no footage of it, but I did actually clearance this tube a little bit for the front diff. It did clear without it, but I wanted just a little bit of extra clearance. And then I added this gusset here to tie this together since I had notched it. I also somehow didn't get any footage of making. I actually machined this on the milling machine and welded this extra gusset. I showed this one, but anyways, I also added this little extra gusset to tie these together that goes across where the control arm goes. Anyways, I couldn't be more excited about how this turned out. Hopefully the internet doesn't beat me up too bad about the welds. but I think it looks great, and it's ready to get the rack mounted and go back in the car for good. And if it all works out, which I'm sure it will, over the winter I'll take it out and actually get it powder coated, but for now I just spray bombed it. And here's the rack mounted before going into the car. And after all the paint, here's the cross member installed in the car. It all turned out really great, fits well. As you can see, it provides a lot more clearance for everything. It'll make it easier to access things in the future with the all-wheel drive system. I even have the sway bar mocked up in there, not fully bolted in quite yet, because I'm going to work on the axles next. But the sway bar fits, and I have these rear bars, the outriggers, I guess I'm calling them, that go back to the chassis. They fit in just great, and as you can see, the rack is clearing everything with my custom mounts. Once again, big shout out to BMR. As you can see, it turned out fantastic. A lot more clearance versus the modified factory cross member, and should make it a little more future-proof for future modifications too. Well, that's a wrap in another episode of the all-wheel drive Mustang project, Project Traction. Once again, I want to do a huge shout out to BMR for supporting the channel. I'm extremely impressed with the quality of the Tubular Front Crossmember they provided. And if you want to get your own, obviously not modified for all-wheel drive, I do have a discount code. In tradition with my whole project, it's Traction7. I'll put it on the screen here, but Traction7, all caps, and you can get yourself a little discount and get yourself a pretty kick-ass Tubular Front Crossmember or any other BMR components for that matter. And if you want to give it a big thumbs up, that does help the algorithm quite a bit, so I really appreciate it. Any questions or comments, leave them below. And once again, thanks for watching.